Okay, so we are talking about continuously compounded interest today. That means that interest is being accumulated nonstop. We have a special formula, and that formula is A equals P times E raised to the RT power. A is the amount of the account at the end of however many years you're looking at. P is your principal amount. R is your interest rate, and then T is your time in terms of years. So A equals P-E-R-T. So suppose you deposit $700 into an account paying 3% annual interest compounded continuously. What is the balance after 8 years? Now, let's identify everything. So 700 is what you're depositing, so that's going to be your principal. 3% is your rate. However, you need to put it in a decimal form, so it's going to be 0.03. It's compounded continuously, and your time is 8. So that's how we plug it into A equals 700 times E raised to the 0.03 times 8 power. Now you can put in the calculator 0.03 times 8, and you get 0.24. Your next step here is you're going to do e to the 0.24 power into the calculator and multiply that by 700. And you get that the balance after 8 years is about $889.87. So we're going to suppose you deposit $700 into an account paying 3% annual interest compounded continuously. How long will it take for the balance in your account to reach $1,200? Now, this one's a little different. 700 is our principal. 0.03 is our rate. We know what our A is. Our amount we're looking for is $1,200. So we're looking for time. So we get 1,200 equals 700 times E raised to the 0.03 T power. So we're looking for T. So our first step in solving for T is we're going to divide both sides by 700. So 12/7 equals E to the 0.03 T power. And now I don't have anything to do other than put this in logarithmic form. So I've got the log base E of 12/7 equals 0.03 T, which log of E is the same thing as the natural log. So I'm going to be taking the natural log of 12/7. So natural log of 12 divided by 7. So I get 0.5389, it goes on and on, equals 0.03 T. And now I need to divide by 0.03 to get my time. So I get that the time is about 17.967 years, which is also about 18 years. So my time, I'm going to write it over here, is about 18 years. Okay, how much would have to be deposited into an account paying 3% annual interest compounded continuously in order to reach a balance of $1,500 after 12 years? So here, I've got my rate is 0.03. I've got my balance at the end. So my A is 1,500. I've got my time is 12 years, so I'm looking for my principal. So 1,500 equals my principal times E raised to the 0.03 times 12 power. So 1,500 equals P times E raised to the 0.36 power. Okay, and now to find my principal, I'm going to divide by e raised to the 0.36 power. And in my calculator, I'm going to put in 1,500 divided by e raised to 0.36 power. And I get $1,046.51. So that's how much I would have to deposit into an account. And in 12 years, I would get $1,500. So if I was just asked how much interest I would earn, I would now need to do $1,500 minus $1,046.51. So the amount of interest earned is only $453.49. Okay, so you might sometimes be asked just how much interest was accrued, and that would be the subtraction. So you would take your principal amount and subtract it from how much you ended up with. All right, suppose you deposit $700 into an account paying 6% interest compounded continuously. What's the balance after 7 years? So we're looking for A. So A equals my principal is 700 times E raised to my rate is 0.06 times my time is 7. So A equals 700 times E raised to the 0.42 power. So when I put that in the calculator, I get that A is $1,065.37. Okay, suppose you deposit $700 into an account paying 6% annual interest compounded continuously. How long will it take for the balance in your account to reach $2,500? So I know my A, so $2,500 equals my principal is 700 times E raised to the rate is 0.06, but I'm looking for my time. So I'm going to be solving for T. So my first step is I'm going to divide both sides by 700. So I get 25/7 equals e to the 0.06 t power. I can put this in logarithmic form. So the log base e of 25/7 equals 0.06 t, which the log of e is actually the natural log. So in the calculator, I'm going to put the natural log of 25 divided by 7. And that's 1.2729 going on, and that equals 0.06 t. So now I'm going to divide by 0.06, and we get that our time, our t, is about 21.22 years. And last example, suppose you deposit money into an account paying 3% annual interest compounded continuously. How much would have to be deposited in order to reach a balance of $1,950 after 10 years? So I'm going to be searching for my principal amount. So my A is 1950 equals looking for the principal times E raised to the rate is 0.03 times time is T, so 10. So I have 1950 equals P times E raised to the 0.3 power. And I'm just going to divide 1950 by E raised to the 0.3 power. So 1950 divided by E to the 0.3. And I get $1,444 and 60 cents. So it would be D. And that is it for continuously compounded interest.